Hello, everybody. We are Project Team 22032, and this is MIS Flatfoot Reconstruction.
Flatfoot is a common foot deformity that occurs in nearly 18 million people across the U.S. where the arch of the foot is flattened, allowing the entire sole of the foot to touch the floor. This condition has been shown to affect the quality of life in a person with their ability to run, walk, or even stand comfortably. There are multiple ways to correct flat foot that have been standardized, but the subtalar fusion surgical procedure that we are focusing on has not been standardized using an MIS approach. An MIS, or minimally invasive surgical procedure, is done using small incisions and few stitches. This approach leads to less scarring, damage to healthy tissue, and faster recovery times compared to that of the traditional approach. Our team has developed two specialized surgical tools for this procedure. These tools are a 5-flute Burr and a curved Burr guide. The Burr was designed to have 5 flutes that are deep and wide to cut away and remove large amounts of cartilage without clogging or slowing down the procedure when used with the surgical drill. The Burr guide was specifically designed with a curved body to contour the lateral malleolus, and a 22-degree angle was added to allow for a better approach into the joint space. And more features are listed here.
Now we will get into some key differences between our surgery and the old approach. While both approaches work to correct flat foot, the old approach is not minimally invasive and takes about a 5 to 7 inch incision. As well as that, our new approach makes use of a surgical guide, which furthers the consistency of the operation. This guide should also allow us to make it a standardized surgical procedure throughout different hospitals throughout in the country.
Our methods to procure our final design was to first create an initial design, procure it at Paragon 28 headquarters, then test it on site in the cadaver lab with our surgeon, Dr. Brinker. We would then reiterate the design once it was tested and its problems were figured out. This led to the discovery of necessary features in our final design, such as curvature to increase stability, keyhole access to ensure no overcutting or undercutting, as well as a joint locator to ensure that we are placing the guide in the correct space. For our results, we will be showing you the full procedure that will demonstrate the full capabilities of our Burr and guide tools.
All of our testing was completed at the Paragon 28 facility located in Denver, Colorado. To start, we will show an overview of the surgical station. Here we can see various K-wire pins, a ruler, a joint distractor located in the back, the surgical drill that we will be using, a soft tissue preserver, and auxiliary surgical equipment that will be used in the procedure. The surgeon will begin by using a C-arm X-ray to locate the sinus tarsi, which is located between the talus and the calcaneus. This will help indicate where the subtalar joint is located and the glide placement in the future. Once the sinus tarsi has been located, the surgeon will place a K-wire pin to mark its location. The surgeon can now use this marker to make a preliminary incision on the lateral anterior side of the foot. The guide can now be placed into the slot to ensure that the fit is appropriate and the size meets the requirements. They will next place a K-wire pin in the provided slot on the guide. With the help of the C-arm X-ray, the surgeon can use the K-wire to align the guide with the subtalar joint as seen in this image.
The surgeon will then place 2 K-wire pins on the insides of both slots in the surgical guide. The first pin will be drilled into the bottom edge of the talus bone. The second pin will be drilled into the top edge of the calcaneus bone. The pin placement is then confirmed via C-arm X-ray to ensure adequate anchorage to the bones. The incision should be no more than 1 inch in length in order for the procedure to be considered minimally invasive. The surgeon will then place the guide back over the K-wire pins in order to prep the area for distraction. The surgeon will place the joint distractor over the 2 pins and distract the joints as far as the guide allows. The guide is built with a fixed distraction distance, both allowing for room to burr out cartilage while also not exposing too much of surrounding soft tissue. After distraction, the joint will then again be confirmed via the C-arm X-ray. Here, the surgeons confirm that the talus and calcaneus bones are properly distanced. Now the cartilage removal can begin. With the guide, K-wire pins, and joint distractor still in place, the surgeon will insert the burr attachment and drill into the guide and begin burring the area. Here, the surgeon is testing out the keyhole feature of the guide. This is designed to keep the burr inside the joint space throughout the procedure. In this step, the surgeon will burr the cartilage away from the facets and remove the cartilage from the surgical site. This is repeated until all or most of the cartilage is removed from the subtalar joint. The surgical guide is designed with a minimum and maximum angle access. These angles were determined from a 3D foot model and are in place to ensure there is no over or undercutting of cartilage. As you can see here, the surgeon has just cleaned off the burr tool and is going back into the surgical guide for a second round of burring. The burring portion of this procedure can take between 15 and 20 minutes. The time variance can be caused by the individual BMIs of the patient or the differing foot anatomies from patient to patient. The C-arm X-ray is again used to confirm the cartilage removal from the joint space. A large white space in between the talus and calcaneus bones indicate that adequate cartilage was removed. Once there has been adequate cartilage removal, it is time to close the incision. The surgeon can begin by taking the joint distractor, guide, and K-wire pins out of the incision site. Once all of the tools are removed, the incision site can be cleaned and sewn up. Here, the incision wasn't actually closed as this was a mock demonstration procedure, but normally this is where the incision would be closed. As a last confirmation measurement, you can see again here that our incision length is coming in at about 1.5 centimeters.
Overall, our developed system can successfully resect the subtalar joint to prepare for bone fusion. The guide and the burr can be used consistently on different feet. The method is minimally invasive, and a standard procedure has been created for more precise and accurate results.
The next steps following the removal of cartilage would be to insert a graft into the joint space, followed by a Paragon 28 monster screw being inserted into the heel for a complete bone fusion. Because of this, we propose another year for this project to allow additional guides to be designed for accessing the medial and anterior facets. Accessing these facets will help the surgeon create a better fusion to the joint space with greater bone-to-bone contact and provide a more complete standardized surgical technique.
Lesson learned: design timeline for medical devices is complex. We learned valuable project organization skills, and we learned effective ways to implement feedback into design.
Lastly, we would like to thank our Paragon 28 sponsors, Joe and Mike, for their advice and guidance throughout the course of this project, and Dr. Brinker for her help on hands-on testing. Finally, we'd like to thank our mentor, Pat, for his continuous support throughout this project. Thank you.